Okay, so the next idea in terms of angles we're going to cover has to do with triangles. Now, triangles, like every other polygon, have a specific measure of its internal angles, okay? Which is to say that if you look at a triangle, it might look like this with 60-degree angles all around. That looks too small. Is that too small? A little bigger? You might get a triangle that looks like this, right? You might get a triangle that looks like this. Now, what all of these have in common is that all of the angles add up to 180 degrees, okay? So this little sign is the angle sign in geometry. And I just did an apostrophe S on it just to say that all those angles add up to 180 degrees, okay? So no matter what triangle we're looking at, the angles are always going to add up to 180. It doesn't matter if it looks like something super skinny like that, right? It doesn't matter if it's a right triangle or an equilateral triangle or whatever. All triangles are going to have all their internal angles are going to add up to 180 degrees. So when we look at a problem like this, we have three angles. They need to add up to 180 degrees. Well, what's the measurement of this angle right there? Allie?
60 degrees.
How much?
60.
No, it's not 60.
Oh, wait, sorry, it's the 90.
It's 90, right? It's that little, so any angle, this means 90 degrees, okay? So we're going to have 90 plus 45 plus x plus 46. Now you'll see here it says solve for x. Now, so I'm going to combine all these like terms and I'm going to get 180 equals 181 plus x. Now, to solve this, I have to subtract 181, right? It's a standard one-step equation, right? And I get -1 equals x. Now, some of you right now are going, how is that possible? You can't have a negative numbered angle. Now, remember, we're not talking about the measurement of the angle. We're talking about the value of x that is right there, all right? So the answers to these problems can indeed turn out to be negative, okay? So don't let it freak you out when you find it, because you're going to be like wondering what's wrong with you and what have I done wrong and why is it that my parents don't love me any? Oh no, sorry, that's a different problem. Sorry. Let's take a look at, these are all pretty easy ones, but that's okay. Let's take a look at number 8 then, shall we? So number 8, I've got, again, I have three angles. They're going to all add up to 180 degrees. Whoop. And I think, again, you can see where this goes from here, right? This isn't hard. This is basically the same kind of stuff we were doing yesterday and the day before. It's just a different object and a different number that they combine up to, right? So this isn't hard, and that's okay. New information doesn't have to be hard, right? It could just be a quick little thing of something you kind of go, oh, well, okay, I get that, right? Yes, Aaliyah.
But I still don't understand it.
Okay, what don't you understand?
And the whole process of solving it.
Okay, do you understand that these angles add up to 180? Is that a yes? Okay. Nodding your head is, yeah, you realize that video cuts out, but if you say yes, I can usually hear it better than you nodding your head quickly. So all these angles inside here add up to 180. Well, there's my number 180. Well, there's a 79 and a 46 and a 3x plus 19, right? So I'm going to add all three of these angle measurements together and set them equal to 180. Then I'm just going to do combining like terms and solving an equation to find out what the value of x is. Yeah? Aaliyah, just so you know, if you ask a question and then I ask whether or not you understand it, I kind of need to have that answer back from you so that I know that we're at end of job for helping you. So does that make sense now?
Yes.
Okay. I it's okay.
Her
Just like Earth to Aaliyah,
Her audio-
Earth to Aaliyah. Hello, did that make sense? Yes, no, maybe so. There's a hippopotamus
audio's
in my
cutting out,
bathtub. I mean, something here, right? Now, let's look at these little bad boys. Now, I want you to think about when we have two parallel lines come together, and then we have a line that goes through them, okay? So we're going to say this is line AB, and this is going to be line CD, okay? Now, if these two are parallel, if AB is parallel to CD, go right back out a little bit. Now I'm a little too zoomed in. My mic's cables are getting wrapped up around each other. So if these two are parallel, there are certain things that we know in mathematics and in geometry about the angles that they form. Now, I'm going to show you something, and I want you to kind of follow along with me on it. If I tell you that if this angle has a measurement of x, I'm going to tell you that this angle has a measurement of 180 minus x. Does that make sense? Think about their position. Think about where these two angles are. Does this make sense? It does, doesn't it? Because they're on a straight angle, right? They're on a line, which means by the supplementary angle principle, this total thing is 180 degrees, right? So if this is x, then the other angle is just going to be 180 minus x, because it's going to be whatever is left over after we take it away from 180, right? And we did that on the sheet we just finished, right? We did some of those supplementary angle things, right? Well, so here's another one. I know this is 180 minus x because these two are vertical angles, right? Remember, they're opposite angles where they hit an intersection. But I also know that that's true because those are also supplementary angles, right? But then this has to be x because these are vertical angles, but also because those two angles are supplementary angles, aren't they? So what we find is that when we have lines intersect with each other, they create a pattern, AB, AB, in terms of the size of the measurement, okay? Now, if these two lines are parallel and this line is coming in at a specific angle that does not change, then this angle down here is also 180 minus x. Because this line is coming through this parallel line at exactly the same angle as it came through the top parallel line, right? Now remember, since they're parallel, they are exactly untouching. They will never intersect, okay? Also, they're on the same plane. Parallel lines are lines on the same plane that never intersect, okay? So if this was, say, angle of 60 degrees, just saying, I'm not saying that's what it is, I'm just saying, let's say it's 60. Well, if it hits this line at 60 degrees, well, then this would also be 60 degrees because it would hit it at the same exact angle because these two lines are exactly parallel. What do you think about that? Does that make sense? So if you think about it, it'd be like when you were at home and you'd set up like an experiment. You go, okay, hey there. You say, okay, I'm going to set this up. And then I put that there. They're the exact same angles, right? You're going to know that this is here and this angle here are the same because it's cutting through these two lines. Think about railroad tracks, right? I mean, they're the closest thing to parallel lines that we really see in the real world, right? Because if they aren't parallel, good luck keeping the train on the tracks, right? And that's kind of a big deal. And I can promise you, when they install those railroad tracks, they measure those to make sure that they are exactly the same distance apart at multiple spots to make sure that they're not going to have a problem with something, okay? So these are called corresponding angles. So what the rule of corresponding angles tells us is that if these two lines are parallel, any line that comes through them, which is called a transverse, these two are parallel. Wow, I spelled it right. Don't you hate spelling the word parallel? It never looks right, does it? Do you ever know something, whenever you write it, you're like, it doesn't look right? Well, look at the middle. It's got those two L's. Those are the parallel lines. It's a great way to remember whether or not you spelled it right or not. You like that? People that have spelling issues like I do, you got to come up with tricks like that to remember how to spell words that you don't see that often. So the rules say that if a transverse if a line cuts through both parallel lines, it forms congruent angles in the same pattern. So if this was 70, this would also be 70. If this is 70, this is 110, right? Because 110 plus 70 equals 180, right? Well, if this is 110, then by the rule of vertical angles, this is also 110, right? Because they're opposite angles of intersecting lines, and we know that opposite angles are congruent. Well, again, now I can say that this is true because not only because these are corresponding angles, but because 70 and 110 are going to make a 180, and since they're on a line, those are supplementary angles, right? And then this has to be 70 because these are vertical angles. And then this is 110 because these are vertical angles, right? And then this is 70 because these are vertical angles. Now, if I throw another parallel line in here, it's going to have the exact same pattern. So the basic concept here is, because the lines that it is crossing through are parallel, then it hits them at exactly the same angle. Because a line doesn't just suddenly go, ooh, I hit that one at 60, but now I'm going to veer to the right just a little bit. Now it's going to be 54. Because lines don't do that. Lines are completely straight. So if these are both parallel lines, when that transverse line comes through, it's going to cut it at exactly the same angle on both of those two lines. So I'm going to find that worksheet that I want to give to you guys, because it includes like all of this stuff. And so you get problems that look like and it'll give you, this is like 70, and it'll give you some other number somewhere, and then it'll have like, tell me what the measurement of that angle is way the heck over there. And so using all these different rules about supplementary angles and complementary angles and vertical angles and corresponding angles, all these different rules about how angles work together, okay? It allows you to be able to basically march across this figure. So like that's going to be 70, right? Because those are vertical angles. And so let's say I gave you 30 here. This would have to be 80. If this is 80, this is 100. And you can see how you could kind of keep moving across this figure until you finally get to X, and you have a way that you can calculate what the value of X is. I really want to find it because, frankly, for those of you that are like math geeks, you're going to love it. You're going to think this is like a fun exercise in math, because it's really like just, it's a puzzle, right? So you're like, okay, I could do this. This is cool. Okay, what are the rules that I have to, okay, I can find that one. Now I can find this one. Okay, I found this one. Oh, that means this one is this. And it actually gets to be pretty fun, because you're finding the value of different angles based on your knowledge of how angles work together. Well, yeah, Jacoby, because we're not there yet, right? We're going to be working on it. So does this stuff make sense, guys? This transverse stuff, does that make sense? So let's look at this one. Now, let's look at this one right here. This is going to be kind of in a small way. So I need to blow this up a little bit. So these two lines are parallel. See those two little arrows there? They're telling you that these two lines are parallel. And now that might look like it's perpendicular, but unless it's got that little square on it, you cannot make that assumption. Okay? You can never assume what something is. You always have to it's either there or it isn't. If it's not there, then you have to prove it. If it's there, it's already being given to you, right? So if on this it gave you a right angle sign, then you know it was 90 degrees. Now, corresponding angles, right? If this is 4x plus 2, so is this, right? Because of how corresponding angles work. Because it's in the same place on where those lines intersect, right? Now it's telling you that these two have the same value, right? Because they're vertical angles, right? Now remember, since it's using X, we don't freak out. We don't go, no, they're not the same. No. Calm down. We don't know what X is yet. We're going to figure it out. Just relax. No, it's not possible. Evil must destroy. No, calm down. So I'm going to set these two equal to each other. Okay. Now, I just have to solve this. Now I just have a simple multi-step equation, don't I? So I'm going to take this one and I'm going to move it over, and it's going to become negative 44x. And that's going to give me 2x minus 2 equals 2, right? Does that follow? Right, because I'm just solving this multi-step equation now, right? So when I subtract 44x from 46x, I have 2x minus 2 equals 2. Now I'm going to add 2, and now I have 2x equals 4. Divide by 2, x equals 2. Not sure? Plug it back in. So 46 times 2 plus 2, does it equal 44 times 2 minus 2? Wait a minute. Sorry, this is minus, this is plus. My bad. So what's 46 times 2? 92, right? Minus 2 equals 88 plus 2. This is 90. This is 90. So I plugged my value back in, and I found that these two equations have the same value regardless of not having the same form. Because I could have also said that it's 45x, right? Wouldn't 45x work as well if x is 2? Because then it would be 90 again, right? Couldn't I do 100x minus 110? Wouldn't that also be a valid way to express it? Because this is still going to come out to be 90 if x is 2, right? So remember, since we're working with variables, math is going to look a little different. So we have to be able to separate out the measurement of the angle from the value of x. Yes? Does that make sense? One is part of the other. See? I know. Please raise your hand if you understand what I'm saying. Yes, I get that. That makes sense, Mr. Easley. No? So do you understand that x is 2 because we figured it out, Elliot? Okay. So I just showed you other ways where if x equals 2, it also ends up being 90. Yeah, Allie, what's up?
So what would be our other angle at the top?
They're going to all be 90, aren't they?
So all the missing angles
Well,
are
look
90?
at it. Well, look at it. If this is 90 and this is 90, wouldn't that have to be 90 based on supplementary angles? Because 90 plus 90 is 180, right? And if this is 90, then this is 90, right? So basically 90, 90, 90, 90, 90, 90, 90, 90. Because this is actually a parallel line. I mean, a perpendicular line. And of course, we know that the definition of a perpendicular angle is where two lines come together at a 90-degree angle. That's what perpendicular lines are, right? You guys remember that? Does that vaguely remember? Okay, so remember, When you have two lines that come together at a 90-degree angle, we say that these are perpendicular. Okay? Right? Parallel lines are ones that never touch. Right? Skew lines, remember skew, are lines that are usually outside of, they are usually not in the same plane, so that they don't even intersect. So we have 20 questions for tonight. That's not a big deal. The first 10 are on the angle sum theory, or the triangle angle sum theory, which is basically that those three angles have to add up to 180. I am going to make these more difficult. Obviously, I'm going to make them more complicated, so they require more thought, more work, more comprehension of how the algebra works within the same concept as the geometry. And I'm going to find out where that stupid worksheet is that I wanted to get, because they have some really, really cool ones that I think you'll actually enjoy. I think you'll see that they're fun to work with, that they're interesting. Okay. Any questions at this point? Okay, so I posted that in Teams. So, and I'll be posting this video. In fact, I'm going to stop recording right now.